Hey everyone, welcome to another episode of Dr. Erin Explains the Universe. Now this one we're just going to geek out about some sci-fi. So we're going to be talking about the verse in Firefly. Now if you've heard my cosmological address video, I kind of rant about how we shouldn't call star systems the verse, as in short for the universe, because the universe encompasses everything. It's the largest thing. If you think about your reference point, that's the Earth compared to countries or cities. And so this is the equivalent of calling a city the Earth when you call a star system the verse. But we're going to let that go. We are here to geek out about Firefly, so we're not worrying about that in this episode. I will refer to the verse as in these 5-star star system in Firefly. If you haven't seen my video on solar life cycles, I can maybe recommend that you watch it, just because we're going to be talking about spectral classes, the brightness of stars, the mass of stars. Just if you're interested in that, I'm going to be referencing it a lot, so I can recommend that you watch that. Otherwise, there's a few scientific things that we just have to go over real quick before we dive in. So the first one that I want to go over is this concept of an AU. So this stands for astronomical unit, and it's the distance between the Earth and the Sun. Now we use this basically as a ruler when we talk about star systems, distances from different stars to planets. It's just a nice ruler. Otherwise, you're going to be talking about hundreds and hundreds of millions of kilometers, and that starts to get a little unphysical. So when we talk about distances to things, we're going to use the unit AU, which stands for astronomical unit, and it's the distance between the Earth and the Sun. So that's our reference point. I'm going to mention that a few times. And the other thing that we want to talk about before we dive in is this concept of a three-body problem. So you may have heard this thrown around before in some physics cycles, especially when you talk about space. But the idea is that it's really easy to have two objects orbit each other, right? If we talk about Pluto and Charon, one of the reasons that we demoted Pluto was the fact that its gravitational field with Charon, their balance is outside of Pluto's surface, so they actually orbit each other. But it's very easy to do that when you have two objects. You just basically make a scale. You say, okay, this weighs this much, this is this massive. Where would that balance be? And then they orbit that point. But if you introduce a third object or a third body into the system, it becomes really unstable. It becomes very hard to have a stable three-body system. So you have two objects that are happily orbiting each other, but then if you want to introduce a third, you have to really strategically place it so they can all continue orbiting each other happily. Otherwise, most of the time, you're going to get one object flung out because it just can't stay in the system. So this is what we call the three-body problem. And when you sort of draw the different gravity diagrams for the center of mass for all of these, there are certain points where you can find a nice balance where you can introduce a third body without much issue. So they continue to orbit okay. And we call these Lagrange points. Now you may hear that when we are exploring space, because we utilize Lagrange points to put different telescopes or satellites in space, because they'll happily just sit at this point that's a balance between the Earth and the Sun's gravity. So I'm going to be talking a little bit about Lagrange points, but that's what we mean, that if you have three objects or three bodies, what points are they going to stably be able to orbit one another? All right, so science aside, let's dive right in. When we're talking about Firefly and we're talking about the verse, we talk about the core, we talk about border space, and we talk about beyond the rim. So we're going to go through each of those. Now the verse has 5 main stars in it. They are all main sequence stars, which means they're in their prime of their life, as it were. They're not near the end. They're not, newly formed. They're going through their life. And then there's also some protostars involved. Now you remember these are sort of just about becoming stars. That they're hot, big, fiery balls of gas, but they've not started fusing hydrogen into helium. And then we also have terrestrial planets and we have gas planets. And we have terrestrial means that they have a surface, gas giants mean that they are made of gas. And then we also have asteroid belts. So we're going to start with the core. Now the core is where we have the star white sun. So in this 5-star system, the center is the white sun. This is where Alliance Space is, and this star is the most massive and the hottest star of all 5 stars. So it is considered an A-class star, which means it's really hot, about 10,000 Kelvin. It's white, so white sun, because it's so bright and so hot and so massive. So you have this big, hot star right in the center of the verse, this star system, and we have some planets that are orbiting around it. Now, around White Sun, there are 2 protostars. So again, these hot balls of gas, but they aren't fusing hydrogen into helium yet. We also have 1 asteroid belt, so just kind of objects that haven't formed a planet, that they're all sort of orbiting this star. And then we also have 14 terrestrial planets, which means that you could stand on the surface, you can walk around, depending varied gravity. But yeah, so we have, just like our solar system, you can imagine, you have the star in the center, which is White Sun, 14 terrestrial planets, 1 asteroid belt, and then 2 protostars that are going around it. So kind of a cool system, but the main thing to take away from that is that White Sun at the core of the verse is the hottest, most massive, and brightest star out of all of them. So then we move into border space. Now, border space has 2 stars. We call them Red Sun and Georgia. Now, Red Sun and Georgia are both 68 AU away from White Sun. So we're going to reference everything as if White Sun is the center and then distances away from that. So again, if you remember, I talked about the 3-body problem. So we now have White Sun at the center and 2 stars that are going around each other. So how can we have that? Well, they actually explain this by saying that Red Sun is at the L3 Lagrange point of Georgia. Now, the L3 Lagrange point, you may have heard if you've heard people talk about like Planet 9 or Vulcan or anything where we're referencing some secret planet that might be in our solar system. We talk about it being at the L3 Lagrange point. That means that you have Earth, the Sun, and then the direct opposite where it's perfectly balanced and you'll never see it. So this is the exact opposite side of this central star. And now Red Sun and Georgia are at the L3 Lagrange point from each other with the White Sun in the center. So they perfectly orbit one another. They're equally distant, so they're both 68 AU away from White Sun, and they just orbit on opposite sides. Pretty cool, pretty awesome. Now, what kind of stars are these? These are going to be our G-type stars. So these are close to our sun. Our sun is a G-type star, and they're going to be sort of yellowish, orangish. Now, Red Sun is the coolest one. Okay, maybe not the coolest one, but the coolest one, because it's red, right? And if you remember on the HR diagram in the main sequence, the red ones are the least massive, and they also have the coolest temperature. And so Red Sun is the least massive, and it sits at the L3 Lagrange point from Georgia and White Sun. So Georgia itself is the closest to what our star is. So it is a G0 spectral type class. Ours is a G2. And again, that just references how hot it is. Remember the HR diagram, they all reference each other's points. So if you say it's a G2 type star or G0 type star, that's going to be a certain temperature, a certain mass, a certain brightness. It also has 1 protostar going around it. It has 2 gas giants going around it. And it also has 15 terrestrial planets going around it. No asteroid belt. And yeah, now like I said, Red Sun is the coldest, reddest, and least massive star out of this entire star system in the verse. It's at remember, it's 68 AU away. Now around it, it has 2 protostars. It doesn't have any gas giants. It has 15 terrestrial planets, and it has 1 asteroid belt going around it as well. And now we're going to go out into rim space. So remember, there's 5 stars in the star system. We've knocked 3 out of the park. So we have 2 left. So the last 2 that we have are Kalidasa and Blue Sun. So we have White Sun, Red Sun, and Blue Sun. So beyond the rim, so we have the core, border space, and now we're beyond the rim. This is where we have Blue Sun and Kalidasa. So these are both F-type stars, which means that they are slightly hotter and slightly brighter and slightly more massive than Georgia and Red Sun. So hope that makes sense. And we'll go Kalidasa is the first one. Now these aren't balanced at all. These are orbiting separately. Kalidasa is 121 AU away, so it's about twice the distance that you get from Georgia to White Sun. Then you have another equivalent distance out to Kalidasa. It also has 1 protostar orbiting it, 3 gas giants, and 17 terrestrial planets going around it. So now you have Blue Sun, which is again an F-type star. Blue Sun is going to be, aside from White Sun, it's going to be the second hottest, second brightest. It's blue, so there you go. And it's going to be 180 AU away, so it's almost 3 times the distance that you have from the White Sun out to the Red Sun. It has 1 protostar going around it. It has 2 gas giants. It has 1 asteroid belt, and it only has 6 terrestrial planets going around it. So that's a quick tour through the verse. I hope it made sense to you. Again, now if you think about it, we'll just recap real fast. You have white sun in the middle, and then you have Georgia and red sun that are equally distant from the center, and they're on opposite sides of white sun. That makes up our border space. And then you get further out and you get Kalidasa and blue sun, which are going to be slightly hotter, slightly more massive, and that makes up beyond the rim. Now, with a 5-body system, this is pretty complex, and it seems that they all formed out of the same cloud because you have really similar structures to them, and as far as I can tell, it's all kind of on the same plane. The only one I'm not totally sure about is blue sun, just because it's the furthest one away, and it's not quite sure if it's at an incline or anything, but given the similar structure, I would want to say that these are all formed out of the same nebula to make up this star system. And how you're able to have 5 stars that are orbiting each other happily is a little bit difficult, but you know what? There was enough thought put into their colors, their spectral types, their masses. I'm willing to give it a pass. They even throw in an L3 Lagrange point, so we're gonna call it good. So thanks for watching, and remember, no power in the verse can stop us. Catch you next time.